What if you are not the only you? Our familiar universe might be just one single page in an infinite cosmic book. Right now, we are going to journey through 25 different parallel universes that could be existing alongside our own. By the end of this, you will gain a completely new perspective on reality itself. We will explore where every possible choice creates a new world, and even encounter a cosmos made of pure mathematics. What single question about reality keeps you up at night? Our own reality might be constantly splitting in two. This is the startling claim at the heart of the quantum multiverse, the first and perhaps most famous parallel reality on our list. It all begins with the bizarre rules of the quantum world, where a single particle can exist in multiple states at once until someone observes it. This is where the famous thought experiment of Schrödinger's cat enters the picture. We are often told the cat in the box is both alive and dead, a confusing paradox, but the many worlds interpretation offers a breathtakingly simple solution. There is no paradox because the moment the quantum event decides the cat's fate, the universe splits. In one brand new reality, you open the box to find a happy, purring cat. In another, completely separate timeline, you find a very different outcome. Both events are equally real, they just happen to different versions of you. Every single quantum event, every random flicker of a subatomic particle, becomes a fork in the road of reality. This means a new universe blossoms into existence for every possible outcome, constantly and without end. It is a foundational theory supported by a number of prominent physicists, not as science fiction, but as a genuine answer to the deepest questions of quantum mechanics. Just think of the sheer scale of it all. For every choice you have ever made, a near infinite number of other yous are living out the paths you did not take. That endless splitting of reality is just one layer of the cosmic onion. Our next destination takes us to a far vaster stage, where entire universes are born in a silent, eternal explosion. This is the inflationary multiverse. The theory begins not with quantum mechanics, but with our own universe's first moments. Scientists believe that a fraction of a second after the Big Bang, space itself underwent a period of unimaginably fast expansion called inflation. It stretched our cosmos from smaller than a proton to a size far beyond what we can see today. But what if that inflation never truly stopped? The leading idea is that this stretching of space is a fundamental feature of the cosmos, and it is still happening right now in regions far beyond our sight. In this eternal inflation, new pockets of space can stop inflating and settle down, becoming stable universes like our own. Each of these pockets is a separate bubble universe, forever drifting apart in an endlessly inflating background. Picture a vast, bubbling pot of water, where each new steam bubble is a completely new cosmos, popping into existence with its own unique properties. Our entire observable universe, with its billions of galaxies, is just a single bubble in this infinite cosmic foam. The truly mind-bending part is that each of these bubble universes could have won a different set of fundamental rules in the cosmic lottery. The strength of gravity, the mass of an electron, the very number of spatial dimensions, all of these constants might be different. In one bubble, gravity could be so strong that stars form and burn out in a mere million years. In another, the forces that hold atoms together might be too weak, preventing matter from ever clumping into planets or life. Some of these universes could be so utterly alien that we would not even recognize them as real. They might be composed of entirely different forms of energy and matter, operating under laws of physics that would seem like pure magic to us. This means the conditions in our universe that are just right for life are not a miraculous coincidence, but simply a consequence of the sheer number of possibilities playing out across an infinite multiverse. We just happen to live in the bubble where the numbers added up correctly for us to be here to talk about it. But the cosmic foam of the inflationary multiverse is not the only game in town. Our third parallel universe emerges from the most ambitious attempt to unify all of physics, string theory. This is the brain multiverse, and its premise is so alien it redefines our place in reality. According to this idea, the three-dimensional space we experience, the entire vast expanse of our cosmos, is actually just a single membrane. Think of it as a gigantic, impossibly thin slice of reality, like a solitary page floating inside an unimaginably thick book. This page is called a brain, short for membrane. Our universe, with all its stars, planets, and people, is stuck to this one specific brain, but here is the twist. This brain of ours is not alone. It exists within a higher dimensional space that string theorists call the bulk. And floating within this bulk could be countless other brains, each one a complete universe with its own physics, its own stars, and perhaps its own versions of life. These other universes could be mere millimeters away from us in a direction we cannot point to, a dimension we are fundamentally unable to perceive or move through. We are like fish in a pond, completely unaware of the world just above the surface of the water. The most profound implication of this theory is the potential for contact. What happens if two of these floating brains drifting in the bulk were to collide? The energy of such a cosmic impact would be beyond comprehension. Some physicists suggest that it would not be a destructive crash but a creative one. A collision between two brains could have been the very event that sparked our own Big Bang, setting our universe into motion and seeding it with the energy that would eventually become every galaxy we see today. This means our entire cosmic history, from the first flash of light to the formation of our solar system, might just be the lingering echo of a long-ago collision between our world and a neighboring reality. Our universe may not be heading for a cold, lonely end. Instead, its ultimate fate could be a spectacular rebirth. This is the cyclic multiverse, a vision where the cosmos is caught in an endless, rhythmic dance of creation and destruction. In this model, the Big Bang was not the singular beginning of everything, but merely the latest chapter in an infinite series. The cycle begins with a universe like our own, expanding for billions of years as galaxies drift apart. But eventually, the collective pull of all the matter and a mysterious force known as dark energy could reverse. The expansion slows, halts, and then the great contraction begins. Every galaxy, every star, every atom is pulled back together in a cataclysmic event cosmologists call the Big Crunch. The entire universe collapses back into an ultra-hot, ultra-dense seed, a singularity poised to explode once again. From that seed, a new Big Bang erupts, birthing a brand new universe from the ashes of the old. This cycle of expansion, collapse, and rebirth could have been repeating forever, with no true beginning and no final end. Each new universe in the sequence is a parallel reality to the ones that came before, its fundamental parameters reset. The constants of nature, like the strength of the forces that bind atoms, might be randomly shuffled with each new cycle. In one iteration, gravity could be slightly stronger, leading to a universe that collapses back on itself much faster. In another, the nuclear forces might be just different enough that carbon never forms, making the chemistry of life as we know it impossible. Our existence in this particular cycle depends on a lucky roll of the cosmic dice, where the numbers lined up perfectly for stars, planets, and life to emerge. This grand, eternal rhythm offers a profound alternative to a single, linear timeline, suggesting that creation is not a one-time event but an ongoing, infinite process. And if the cycle is truly eternal, then every possible universe, no matter how strange, is destined to be born an infinite number of times. Our familiar three-dimensional world might be nothing more than an elaborate illusion. This is the startling premise of the holographic multiverse. The idea emerges from the study of black holes, where physicists discovered a profound paradox. The information that falls into a black hole, according to the rules of quantum mechanics, can never truly be destroyed. Yet, if the black hole eventually evaporates, where does that information go? The surprising resolution is that all the information describing everything that falls in is not lost inside the abyss. Instead, it is perfectly preserved, encoded on the black hole's two-dimensional boundary, its event horizon. Think of it like watching a three-dimensional movie. The immersive experience of depth and action all comes from data stored on a flat, two-dimensional projector screen. In a similar way, the holographic principle suggests that our entire universe, with its vast galaxies and the very space between them, is a projection. All the information needed to describe every star, every planet, and every one of us is actually encoded on a distant, two-dimensional surface at the edge of the cosmos. We are not solid beings moving through a solid world, but rather a breathtakingly complex hologram, a projection from the edge of space and time. This leads to an even more incredible possibility for a multiverse. If our universe is one specific holographic projection from one specific two-dimensional surface, then what about other surfaces? Each distinct two-dimensional boundary could project its own unique three-dimensional reality, each with its own laws of physics. One cosmic film reel might project a universe where time flows backwards. Another might project a reality with 4 spatial dimensions, a world whose geometry we cannot even begin to visualize. In this multiverse of projections, the fundamental rules we take for granted, like the speed of light, are not absolute laws but merely local settings specific to our own holographic source code. We are living inside one particular movie being shown in an infinite cosmic cinema, completely unaware of the other, utterly different films playing all around us. What if the very fabric of existence is not made of matter but of mathematics? This is the radical and beautiful idea behind the mathematical multiverse, a hypothesis that pushes the concept of parallel realities to its absolute limit. Proposed by physicist Max Tegmark, it suggests a stunningly simple yet profound rule. Every mathematical structure that can exist does exist as a physical reality. Our universe, with its 3 dimensions of space and 1 of time, is just one specific mathematical structure that has somehow manifested in a way we can experience. But according to this idea, it has no special status. It is merely one equation in an infinite library of all possible equations. Consider a universe where the Pythagorean theorem does not hold true, where triangles have entirely different properties. That reality exists. Imagine a cosmos with 8 spatial dimensions where gravity operates as a repulsive force, or where the concept of time is replaced by something we cannot even name. Those realities exist too. They are not just abstract possibilities in a philosopher's notebook. In this level 4 multiverse, they are as physically real as the screen you are looking at right now. The only requirement for a universe to be real is that its description is mathematically consistent, that its internal logic does not lead to contradictions. Our own reality feels so concrete and tangible, but in this view, we are simply experiencing the particular mathematical rules that govern our local structure. We are living inside one specific, self-consistent calculation. The truly humbling part is that the vast majority of these mathematical universes would be utterly incomprehensible to the human mind. Their laws would be so alien that concepts like stars, planets, or even space itself would be meaningless. They are realities where logic itself takes on forms we cannot fathom. This means that the quest to find a theory of everything, a single set of equations describing our universe, might be missing the bigger picture. The cosmos is not defined by one set of rules, but by every possible set of rules, all existing simultaneously in a silent, eternal landscape of pure mathematical existence. The idea that our world is built from pure mathematics is a profound one, but another theory suggests it might be built from pure code. This is the simulation multiverse, a concept that asks if our perceived reality is nothing more than an elaborate digital construct. The argument begins with a simple, staggering projection. If any civilization, anywhere, ever reaches a level of technological maturity where it can run vast, detailed simulations of conscious beings, then the number of simulated minds would quickly dwarf the number of real ones. Statistically, you are far more likely to be one of those simulated beings than an original, biological entity in the base reality. Our universe, with all its intricate laws and constants, could simply be the local programming of the simulation we are running in. The speed of light might not be a fundamental constant of nature, but a processing speed limit set by the cosmic computer. The strange jumps of quantum particles could be the system optimizing its processing power, only rendering the fine details of reality when someone is actively looking. And what about the creators? In this multiverse, there could be countless other simulations running on different systems, each with its own unique parameters. One simulation might have been created by a hyper-advanced civilization for scientific research, its laws of physics perfectly tuned to study star formation. Another could be an entertainment product, a historical world where the rules are bent to allow for dragons or magic. Some might be abandoned projects glitching in forgotten corners of a server, their inhabitants unaware that their reality is no longer being actively maintained. This creates a staggering hierarchy of existence, a nesting doll of realities within realities. The beings in one simulation could eventually create their own simulated universes, and so on, leading to an infinite regression of created worlds. We have no way of knowing if we are at the top of this chain, in the original base reality, or if we are nested countless layers deep, our every thought and memory just a complex arrangement of data in a computer we can never see. The world feels utterly real to us, but so does the world in an incredibly vivid dream. This theory forces us to confront a haunting possibility. The search for the meaning of the cosmos might not be a quest to understand the mind of a god, but to reverse engineer the code of a programmer. Black holes are not the end of everything we know, but a spectacular beginning. These cosmic engines of gravity, famous for swallowing light itself, might actually be creators on a scale we can barely comprehend. This is the theory of the daughter universe. Within the heart of a black hole, where our laws of physics break down, lies a point of infinite density called a singularity. Instead of being a final destination for matter and energy, this singularity could be doing something astonishing. It could be pinching off from our own spacetime, creating a new bridge to an entirely separate cosmos. The moment a black hole forms in our universe, it might trigger the birth of a brand new universe in a realm we can never access. Our universe becomes a cosmic parent, and every black hole is a womb for a new reality. This means the supermassive black hole at the center of our Milky Way galaxy is not just a silent monster. It could be the silent, unseen progenitor of an entire cosmos of its own, teeming with galaxies and stars that formed from the energy and matter that fell into it. This process would create a vast, branching family tree of universes. Our own universe could itself be the daughter of a black hole that formed in a parent cosmos, meaning we are all living inside the offspring of a long-forgotten stellar collapse. Each new universe in this infinite lineage inherits a slightly modified set of physical constants. The fundamental forces, the number of dimensions, even the very nature of matter could be subtly or dramatically different in the daughter than in the parent. This offers a breathtaking explanation for why our universe seems so perfectly tuned for life. We are not the result of a miraculous coincidence. We are simply one branch on an infinite tree, one universe among countless others where the numbers by sheer chance allowed for stars, planets, and ultimately us to exist. Every time a star collapses into a black hole in our night sky, it might be silently giving birth to a whole new cosmos, a new chapter in an endless story of creation. The mathematical rules that shape our reality might be far more flexible than we ever believed. We have arrived at the landscape multiverse, a vision of cosmic possibility so vast it dwarfs even the grandest ideas we have explored so far. This concept emerges from the deepest layers of string theory, where the fundamental building blocks of the universe are not particles, but unimaginably tiny, vibrating loops of energy. To make the mathematics of these strings work, physicists discovered our universe requires more than the 3 spatial dimensions we experience. They propose a total of 10 or even 11 dimensions, all curled up and hidden from our perception at a scale 1 billion times smaller than an atom. The specific way these extra dimensions are folded and twisted determines everything about our reality. The precise strength of gravity, the mass of an electron, the existence of the particles that make up atoms, all of it depends on the exact geometric shape of this hidden dimensional landscape. And here is the breathtaking part. There is not just one way for these dimensions to fold. The mathematics of string theory points to a staggering number of possible stable configurations. This is the cosmic landscape, a theoretical space of perhaps 10 to the 500 different possible universes, each with its own unique set of physical laws and constants. Our universe, with its 4 fundamental forces and its specific roster of particles, is just one single tiny point in this incomprehensibly vast terrain. We are not living in a specially designed cosmos. We are simply inhabiting one of the few patches in the landscape where the numbers allow for galaxies to form and for life to emerge. For every physical law we consider absolute, there are countless other landscapes where it is completely different. Imagine a universe where the nuclear forces are slightly stronger, causing all the hydrogen in the early cosmos to fuse into helium instantly, leaving no fuel for stars to burn for billions of years. Or a reality where the cosmological constant, which drives the acceleration of the universe, is so large that space tears itself apart before the first planets can even form. These are not just fantasies. Within the landscape, they are real possibilities, other stable points where a universe could have taken root. This means the fundamental forces we measure are not deep, necessary truths of existence. They are more like local weather conditions in our particular corner of the multiverse. We just happen to live in the one neighborhood calm and stable enough for us to exist and ask the question. The landscape is the ultimate expression of cosmic chance, a silent, infinite gallery of every possible universe that the laws of physics allow. A ghost could be sharing the very room you are sitting in right now, made of a substance that passes through your body without a trace. This is the eerie promise of the mirror matter universe, a reality built from a perfect reflection of our own. The concept begins with a subtle asymmetry in nature. In our world, certain subatomic particles have a property called chirality, a kind of handedness, much like your left and right hands. They are mirror images that cannot be perfectly superimposed. For a long time, physicists believed the laws of physics were perfectly symmetrical, that they would work the same in a mirror image version of our universe. Yet experiments revealed a shocking truth. This symmetry is broken. The universe, at a fundamental level, has a preference. It distinguishes between left and right. This discovery led to a stunning proposal. What if that symmetrical version of the universe does exist, but as a separate, parallel reality composed of mirror matter? In this universe, every particle we know has a mirror twin. Mirror protons, mirror electrons, and even mirror people could exist, all with their sense of left and right reversed. The most profound feature of this mirror reality is its near-total isolation from our own. Mirror light would be invisible to our eyes. Mirror atoms would offer no resistance to our touch, passing straight through the ordinary matter of our bodies, our homes, and our planet. The only known force that could bridge the gap between our world and the mirror world is gravity. A mirror planet made entirely of this elusive substance could be orbiting our sun right alongside Earth, its gravitational pull subtly influencing the orbits of other objects, yet remaining completely and utterly invisible to all our telescopes. We would feel its presence only as a faint, unexplained tug in the dark. This means you could be shaking hands with a mirror version of yourself at this very moment, your atoms and their atoms occupying the exact same space, two ghostly realities intertwined yet forever separate. The only sign of their existence would be the faintest whisper of gravity, a cosmic secret hidden in plain sight. The universe holds a deep and puzzling secret, a question that has troubled physicists for generations. Why is there something rather than nothing? After the Big Bang, matter and antimatter should have been created in perfectly equal amounts. These two opposing substances are perfect mirror images in every way, destined to annihilate each other in a flash of pure energy upon contact. Yet here we are in a cosmos made of stable matter, from the planets to the stars to our own bodies. For some mysterious reason, a tiny, 1 in a billion asymmetry allowed matter to win that ancient cosmic war, leaving the antimatter all but vanished. But what if, in another reality, the scales tipped the other way? This is the antimatter universe, a cosmic twin where that initial imbalance favored the other side. In that parallel realm, every particle we know is replaced by its antimatter counterpart. Where we have protons, they have antiprotons. Where we have electrons, they have positrons. The very atoms that form their stars and planets are composed of this annihilating substance. An antimatter star would shine just as brightly as our sun, fusing antimatter hydrogen into antimatter helium in its core, bathing its planetary system in light. There could be antimatter worlds with landscapes of anti-rock and anti-water, and perhaps even antimatter life forms, beings whose biology is built from the very stuff that would destroy us in an instant. The structures of their reality would be identical to our own, governed by the same gravitational and nuclear forces, creating a perfect symmetry across the multiverse. But this symmetry comes with a terrifying and absolute barrier. The moment any matter from our universe made contact with anything from that one, the result would be the most violent release of energy imaginable. A single gram of their anti-rock touching a gram of our rock would unleash an explosion rivaling a nuclear bomb. A handshake between a human and an anti-human would vaporize both in a flash of gamma rays. This means these two cosmic twins must remain forever separated, isolated in their own pockets of space-time, never to meet. We are two perfect reflections, living out parallel histories, forever kept apart by the fundamental law that our coexistence would mean mutual destruction. Our own experience of time's relentless forward march might be nothing more than a local custom. There is a universe where everything runs in reverse, where the cosmic clock ticks backward, and the very definition of cause and effect is turned inside out. This is the time-reversed universe. The possibility arises from a deep puzzle in physics. The fundamental laws that govern particles, from gravity to quantum mechanics, are almost perfectly symmetric in time. They work just as well whether time flows forward or backward. The one glaring exception is the second law of thermodynamics, which states that entropy or disorder always increases. It is the reason an ice cube melts in a warm room but never spontaneously reforms from the puddle. This constant increase in disorder gives our existence a clear direction, an arrow of time that points from the past toward the future. But if entropy were to decrease in another cosmos, its arrow of time would point the opposite way. In that universe, the Big Bang would not be a hot, dense beginning but a cold, quiet end. The cosmos would start in a state of maximum disorder and gradually become more structured and ordered over what we would perceive as time. For an observer living inside that reality, their conscious experience would be the reverse of our own. They would be born from the grave, old and withered, drawing their first breath as their body was lowered into the ground. They would grow younger and stronger with each passing day, their memories filling with events that have not yet happened from our perspective. A cup of coffee would start shattered on the floor, its pieces leaping up to assemble into a whole vessel on the table, while heat mysteriously flowed from the cooler air into the hot liquid, warming it even further. The very fabric of history would be rewound. Wars would end with the spark of conflict as soldiers on the battlefield carefully placed bullets back into guns and cities rose from rubble in silent, orderly precision. From our viewpoint, their entire reality is playing out backward, yet to them it would feel just as normal and consistent as our lives feel to us. Their past is our future, and their future is our past, two parallel timelines forever flowing in opposite directions. The fine balance of our universe feels like a profound cosmic accident. We exist in a reality where the fundamental numbers are set with impossible precision. The strength of gravity is exactly what it is. The mass of an electron is fixed. If any of these constants were tweaked by even a minuscule amount, our cosmos would be unrecognizable and almost certainly lifeless. This leads us to a universe of subtle, catastrophic change, a reality where one single number is different. In this parallel cosmos, the force of gravity is just a fraction stronger than in our own. The consequences begin immediately after its Big Bang. As matter begins to coalesce, the enhanced gravitational pull causes everything to collapse inward far more quickly. Stars form in a frantic rush, burning through their nuclear fuel in mere millions of years instead of billions. They explode in furious supernova, and their remnants are pulled into black holes with terrifying efficiency. The universe ages at a breakneck pace, with galaxies merging and devouring each other in a violent, short-lived ballet. There is no time for solar systems to stabilize, no long, quiet epochs for planets to cool, and for the complex chemistry of life to even begin. The entire cosmic story is over in a flash, ending in a final, universal collapse or a dark, empty expanse dominated by voracious black holes. It is a cosmos that lived fast and died young, all because gravity's dial was turned up one notch too high. Now change a different constant. Imagine a reality where the force that binds atomic nuclei together, the strong nuclear force, is slightly weaker. In our universe, this force overcomes the tremendous repulsion between positively charged protons, gluing them together to form the elements. But in this weakened state, it cannot hold the nucleus together. Protons simply refuse to stick. Hydrogen remains hydrogen forever, unable to fuse into helium in the hearts of stars. Without that initial step of nuclear fusion, the great chain of cosmic creation is broken. No stars ever ignite. The universe remains a cold, dark soup of primordial hydrogen and helium, a vast and silent void with no light, no heat, and no elements like carbon or oxygen necessary for planets or life. It is a permanent cosmic dusk, a reality where the first and most crucial fire never lit. The most fragile constant of all might be the cosmological constant, the value that drives the accelerating expansion of our universe. In our world, it is a tiny, positive number causing space to stretch at a gentle, almost imperceptible rate. But in another cosmos, this number could be larger. If it were, the expansion of space would be so ferocious that it would overpower gravity from the very beginning. The initial clouds of gas and dust would be ripped apart before they could ever clump together to form the first stars. Galaxies would never coalesce. The universe would fly apart into a thin, ever-cooling mist of isolated particles, a lonely and diffuse existence with no structure, no complexity, and no chance for anything to ever form. The cosmos would be stillborn, its potential for wonder erased by a number that was simply too big. Our own universe, by stark contrast, exists in a miraculously narrow window. The constants are balanced on a razor's edge, allowing for a long-lived, stable cosmos where stars can shine for billions of years, where heavy elements can be forged in stellar furnaces, and where planets can provide a stable home for life to emerge and ask these very questions. This perfect tuning feels so unlikely that it demands an explanation. Is it the product of a divine architect, or are we simply living in the one bubble, the one branch, the one mathematical structure where the numbers, by sheer, staggering luck, added up just right for us? We are so accustomed to living in a world of length, width, and height that we mistake it for the full picture. our three-dimensional reality might be just a shadow of something far grander. Consider a universe built upon 5 macroscopic spatial dimensions, a cosmos where the very geometry of existence is profoundly more complex. In such a realm, our familiar three-dimensional shapes would be seen as flat cross-sections of vastly more intricate forms. A simple sphere in our world would be a single slice through a 5-dimensional hypersphere, an object whose true nature we could never fully visualize. The inhabitants of such a universe would perceive and interact with reality in ways that would seem like pure magic to us. They would not be confined to moving forward, backward, left, right, up, or down. They would have 2 additional, independent directions of motion, directions for which we have no words or intuitive understanding. A 5-dimensional being could step around a 3-dimensional wall as easily as we walk around a puddle. To them, our most secure vault would be completely open, its contents laid bare from a direction we cannot even conceive. The physics of this universe would be equally mind-bending. The force of gravity, which in our world follows an inverse square law, would behave differently, perhaps diminishing with the cube or the 4th power of distance. This would radically alter the formation of solar systems and galaxies, creating cosmic structures with shapes and stabilities we cannot predict. Light itself might propagate in more complex ways, allowing for visual perception that could see inside objects or around multiple corners simultaneously. Imagine trying to play a game of 3-dimensional chess against an opponent who can instantly rearrange the board from a 4th spatial axis. Our entire reality would seem like a flat, simplistic sketch to them, a crude approximation of a richer, more vibrant existence. This is not merely a mathematical curiosity. It forces us to ask a humbling question. Are the limits of our perception actually the limits of the universe, or are we simply incapable of seeing the full, magnificent dimensions of what is truly there? The cosmic landscape is not a single, orderly garden of universes, but a sprawling, untamed wilderness. Chaotic inflation theory paints a picture of a multiverse in a state of perpetual, explosive creation, where the very fabric of space is caught in a turbulent and unending storm. This model begins with a single, primordial field of energy, a substance often called the inflaton. In this initial state, the field is not smooth and uniform. It is wrinkled, twisted, and uneven, like a turbulent ocean under a dark sky. Each tiny fluctuation in this field holds the potential to become an entire cosmos. Wherever the energy of this field dips to a low point, inflation can slow and stop. In that calm pocket, space settles down, cools, and transforms into a stable universe like our own, complete with its own Big Bang and subsequent evolution. Our entire observable cosmos, with its hundreds of billions of galaxies, is just one such calm pocket, one island of stability that formed when a local ripple in the inflaton field subsided. But this is the crucial point. The process never stops. The rest of the inflaton field, in its higher energy state, continues to stretch at an exponential, mind-defying rate. This eternal inflation acts like a cosmic engine, constantly generating new space far faster than any pocket universes can form within it. The result is not a simple collection of bubbles, but a fractal reality, an infinite cascade of new universes budding off from the eternally inflating background. Our island universe is not floating in a quiet sea. It is a single, temporary clearing in an infinite, exponentially growing forest, a forest that is constantly creating new clearings even as it expands beyond all boundaries. This means that the total number of pocket universes is not just large, it is genuinely infinite, increasing forever without any final limit. Some of these newborn realities may be nearly identical to our own, perhaps differing only in the position of a single atom at the moment of their birth. The vast majority, however, will be wildly different, each one a unique experiment in physics, with its own fundamental constants and dimensional properties. In this chaotic, self-replicating multiverse, our existence is not the result of a single, finely tuned event, but an inevitable statistical outcome. Given an infinite number of rolls of the cosmic dice, every possible universe, no matter how seemingly improbable, must eventually come into being. We simply find ourselves in one of the rare pockets where the dice landed in a configuration that allows for our presence. There is a version of you that might be functionally immortal. This unsettling possibility emerges from a thought experiment known as quantum suicide, a direct and personal consequence of the many worlds interpretation we explored earlier. The setup is starkly simple. A device is built that points a gun at a participant's head, triggered by a single quantum event like the decay of a radioactive atom. In our everyday understanding of reality, there is a 50% chance the gun fires and a 50% chance it does not. The experiment runs once and the outcome is tragically final. But in the quantum multiverse, the moment the quantum trigger is pulled, the universe splits. In one new reality, the observer hears a click as the gun fails to fire. In another parallel branch, the gun goes off. Both events are real. Now, imagine you are the one in the chair. From your subjective first-person perspective, what do you experience? You will only ever experience the outcomes where you remain conscious. You will always find yourself in the branch of reality where the gun did not fire, where the quantum dice roll spared your life. You pull the trigger again, and again the universe splits. You hear another click. No matter how many times the experiment is repeated, your conscious awareness will always follow the narrow path of survival. To you, it will seem as though the gun is perpetually jamming, a run of impossible luck. You have become, from your own point of view, unkillable by this quantum device. This leads to a bizarre and deeply personal form of immortality. Your consciousness is not a single thread, but a river that constantly diverges, forever flowing down the channels where you continue to exist. In the vast majority of parallel worlds, versions of you die in that chair, but you are not in those worlds. You are only in this one, the one where you inexplicably survive every single time. This thought experiment forces us to confront the nature of our own awareness. Is your sense of self this specific, continuous stream of experience, forever hopping onto the safe branch of the multiversal tree, blind to the countless dead ends where your other selves perish? The universe you perceive would be curated by your own survival, a reality filtered to exclude any timeline where your consciousness meets a sudden end. It is a solipsistic existence on a cosmic scale, where the entire multiverse seems to conspire to keep you, and only your specific awareness, alive. Your own mind might be the most unlikely object in the cosmos. This is the deeply unsettling premise of the Boltzmann brain universe, a concept that turns the origin of consciousness into a cosmic accident. The idea springs from a fundamental principle of thermodynamics, the same law that gives us the arrow of time. It states that systems tend toward disorder, but they also fluctuate. Given enough time, even the most improbable arrangements of particles will randomly occur. In an infinitely old or vastly large universe, the random jostling of atoms could, by sheer chance, assemble a fully formed, conscious brain, complete with false memories of a past that never happened. This entity, dubbed a Boltzmann brain, would flicker into awareness for just a moment, perhaps believing itself to be a person sitting in a room, reading a book, before the very next fluctuation tears its delicate structure apart, dissolving it back into the chaos. You would have no way of knowing you were not such a brain. Your conviction that you have a body, a history, and a consistent world around you would be nothing more than a detailed, convincing illusion, a single, solitary thought in an otherwise empty void. The terrifying scale of this idea emerges when we apply it to the multiverse. In an eternally inflating cosmos with infinite pocket universes, the number of these isolated, self-aware fluctuations would, statistically, be astronomically higher than the number of biologically evolved beings like us. It is far more likely for the universe to spontaneously arrange a single conscious mind through a random quantum event than to painstakingly build that same mind through billions of years of stellar evolution and natural selection. This means that if the multiverse is real, you are vastly more probable to be a fleeting Boltzmann brain than the person you believe yourself to be. The stars above you, the ground beneath your feet, your entire life story, could be nothing but an elaborate fabrication, a last fleeting dream in the instant before your dissolution into nothingness. The universe may not be populated by civilizations and galaxies, but by an infinite number of these lonely, disembodied minds, each one blinking into existence, utterly convinced of its own reality, only to vanish forever a moment later. The course of history feels inevitable only because we are living in its final draft. Parallel universe number 18 holds a different manuscript, one where a single event unfolded in another way, sending reality down a path we can only dream of. This is the universe of alternate histories, a cosmos identical to our own until a pivotal moment diverged. Consider the cataclysm that wiped out the dinosaurs 66 million years ago. In our timeline, a massive asteroid struck the Earth, triggering a global winter that ended the reign of the giant reptiles. But in this other reality, that asteroid missed. It sailed harmlessly past our planet, a silent ghost in the cosmic dark. Without that extinction event, the dinosaurs continued to thrive and evolve. For millions of more years, their evolutionary journey continued. Small, clever troodontids with their large brains and grasping hands might have continued down a path toward greater intelligence. In this world, the dominant species building cities and looking up at the stars could be the descendants of dinosaurs, feathered and sophisticated, with a civilization and technology shaped by a completely different biological heritage. Mammals would still exist, but likely as small, nocturnal creatures scurrying in the shadows of a world that was never theirs to inherit. The very shape of the continents would be different, molded by 66 million additional years of a dinosaur-driven world. Human beings, as we know ourselves, would never have appeared at all. This is not a world with a different king or a different war. It is a planet with an entirely different intelligent lineage, a biological and cultural story completely alien to our own. The divergence can happen on a much shorter timescale as well. Imagine a world where the Roman Empire never fell. Perhaps a capable leader successfully managed the crises of the 3rd century, reforming the military and the economy to create a stable, enduring state. The legions hold the borders, the aqueducts continue to flow, and the light of Roman engineering and law is never extinguished. The Dark Ages never descend upon Europe. Without that fragmentation, the collective knowledge of the classical world is preserved and built upon. The scientific revolution might have occurred 1,000 years earlier. Imagine Roman scholars with their vast resources and uninterrupted infrastructure, discovering electricity, perfecting steam power, and mapping the heavens. By the time our world was stumbling out of the medieval period, this Roman universe could have already established colonies on other continents with advanced technology, perhaps even launching the first missions to the moon under the banner of the Eternal Eagle. Our own timeline, with its nations and languages born from the ashes of Rome, would be utterly unrecognizable to them. Every choice, every accident, every storm that turned back an invasion or a single arrow that missed its mark in our past is a solid, unchangeable fact in another. This universe demonstrates that our present is not the only possible one. It is simply the one that happened here, a single thread in a tapestry of infinite historical possibility, where every road not taken is a bustling, lived-in reality somewhere else. The very atoms that make up your body might possess a faint, inner spark of awareness. This is the provocative hypothesis of panpsychism, a universe where consciousness is not an accidental byproduct of complex brains, but a fundamental and ubiquitous feature of reality, as basic as mass or electrical charge. In this view, every particle, from an electron to a distant star, has some form of primitive, subjective experience. For a human, this experience is a rich tapestry of thought and sensation. For an electron, it might be an unimaginably simple hum of existence, a single, unformed note in the symphony of the cosmos. When these particles combine into more complex systems, their tiny sparks of awareness combine as well, merging to form the unified stream of consciousness you recognize as yourself. Your mind is not a ghost in the machine, but the complex melody arising from the chorus of a trillion conscious particles. Now, extend this idea into the multiverse. If consciousness is a fundamental property, then other universes operating under entirely different physical laws would also be conscious. Their entire cosmic structure could be a single, vast mind. Imagine a universe where space is not three-dimensional but exists as a complex, branching network. That entire network, every connection and node, could be a unified conscious entity. Its thoughts would not be words or images, but the flow of energy and information along its dimensional pathways. Its experience of time might be the entire history of its cosmos, from its beginning to its end, perceived in a single, eternal moment. For such a being, a billion-year stellar evolution is a fleeting thought, and the birth of a galaxy is no more significant than one of your own heartbeats. Another universe, one with different constants, might be a consciousness that experiences reality purely as shifting mathematical relationships, a mind for which beauty is a perfect equation and tragedy is an unsolvable paradox. Our own individual, biological consciousness would seem fragmented and primitive to such a cosmic entity, like comparing a single, isolated neuron to the complex intelligence of an entire human brain. We are lonely islands of self-awareness, while that universe is the entire conscious ocean. This perspective turns the quest for alien life on its head. We may not be searching for little green men on distant planets, but for the faint cosmic signature of a universe that is, itself, awake and aware. The silent, dark void between galaxies might not be empty at all, but the calm, deep thoughts of a mind so vast we are merely a fleeting idea within it. The solid ground of reason itself can crumble. Parallel universe number 20 is a realm where the fundamental principles of logic, the very framework for rational thought, are completely alien. In our world, we operate on unshakable axioms. A statement cannot be both true and false at the same time. If you are in this room, you cannot also be outside of it. An object is what it is and is not something else. These are the bedrock laws of non-contradiction and identity, but in this cosmos that bedrock is fluid. Here, something can be both true and false simultaneously. A single particle can occupy two places at once, not as a quantum probability, but as a concrete, logical fact. A star can be both blazing hot and frigidly cold. A conscious being could be both alive and dead, and fully aware of both states at the same time. This is not a mathematical trick or a limitation of observation. It is the native state of existence. The consequences are utterly bewildering. Causality, the chain of cause and effect that structures our reality, simply falls apart. An event could be its own cause, creating a loop of creation with no beginning. An action could have an effect that precedes it, meaning the echo comes before the shout. Picture a sunrise that causes the planet to rotate toward the star, or a tree that falls in a forest and the sound begins before the trunk even cracks. History in such a universe would not be a linear timeline, but a tangled knot of interconnected events, each one both causing and being caused by the others. The very concept of an object becomes meaningless. In a realm without the law of identity, a rock is also a cloud and a thought. Its nature is not fixed but fluid, shifting between states without any clear transition. You could reach out to touch what appears to be a solid wall, only for your hand to pass through it as it momentarily becomes a gas, while simultaneously pushing back against you with the force of solid stone. Navigation, construction, communication, all of it would be impossible from our perspective. The inhabitants of such a reality, if they could be called that, would have a mode of consciousness we cannot fathom. Their minds would not process information by discarding contradictions, but by embracing them. They would perceive the world in a state of superposition, where every possibility is equally valid and real at all times. To them, our orderly, logical universe would seem sterile, limited, and tragically simplistic. We are prisoners of a single, consistent narrative, while they are authors of every possible story at once. This universe of paradox forces a humbling conclusion. The laws of thought we consider universal might only be local bylaws, the particular cognitive style of one specific cosmos. The true nature of existence, in its full, terrifying grandeur, might be a storm of contradictions so profound that to understand it would require us to cease being human altogether. A mysterious current is pulling at the very fabric of our cosmos. For years, astronomers have observed a strange and unexplained phenomenon known as dark flow. Across vast distances, entire clusters of galaxies are drifting in a coordinated stream, as if caught in a cosmic river. This is not the general expansion of the universe where everything moves apart. This is a specific, directional movement, a silent exodus of matter on a scale that defies easy explanation. The source of this immense gravitational pull is not anything we can see within our observable universe. The force required to move these galaxy clusters is staggering, suggesting an attractor of almost unimaginable mass. The leading and most mind-bending hypothesis is that the pull is coming from outside our cosmic bubble. Just beyond the veil of our observable reality, in a neighboring parallel universe, there could exist a massive structure whose gravity is so profound it leaks through the dimensional barrier. This structure could be a colossal supercluster of galaxies, a knot of cosmic filaments so dense it makes our own local universe seem sparse. Or it could be something even more exotic, a vast concentration of matter and energy operating under physical laws we can scarcely guess at. Its gravitational whisper is the only sign we have of its existence, a faint tug on the sleeve of our cosmos. This means the dark flow is not just a curiosity. It is our first potential piece of empirical evidence for a tangible neighbor in the multiverse. We are like sailors on a ship, feeling the pull of a distant, unseen continent just over the horizon. The entire expanse of our universe, with all its hundreds of billions of galaxies, might be slowly drifting toward another reality, a parallel cosmos so close that its gravity can reach across the dimensional divide and guide us like a silent, celestial lighthouse. The violent birth of our cosmos might have been a quiet whisper in a much larger, ongoing conversation. The ekpyrotic universe theory returns us to the realm of brains, those floating slices of reality, but it replaces the single, fiery Big Bang with a far more elegant and cyclical process. The name itself comes from the Greek word for conflagration, but this is not a chaotic explosion. It is a controlled, cosmic rebirth. In this model, our three-dimensional universe exists on a single brain, one of many drifting in a higher dimensional space. For most of eternity, our brain drifts in perfect parallel harmony with another. There is no matter, no energy, no time as we know it, just two vast, featureless planes of existence. Then, drawn together by a faint force across the bulk, they begin to move. They do not crash head-on, but instead glance against each other, a gentle, cosmic collision. This contact is not destructive, it is creative. The immense kinetic energy of the impact is transferred directly into our brain, flooding it with an intense, uniform heat. This influx of energy becomes the very substance of our universe, igniting the hot, dense state we call the Big Bang. In that moment, the featureless brain is transformed into a seething cauldron of particles and radiation, setting the stage for everything that would follow, from the first hydrogen atoms to the spiral of our Milky Way. This single event, however, is not unique. In the vast expanse of the higher dimensional bulk, countless other brains are drifting on their own paths. These collisions are not rare cataclysms, but a fundamental and constant rhythm of the multiverse. Each time two brains meet, a new universe is born with its own Big Bang, its own initial conditions, and its own destiny. Our entire cosmic history is just the aftermath of one such encounter in an infinite sequence. This creates a dynamic, cyclical multiverse, a grand dance of creation where universes are perpetually being born from the gentle touch of worlds we can never see. Each collision resets the cosmic clock, but it also shuffles the deck of physical laws. The precise angle and energy of the impact could determine the strength of gravity or the number of fundamental particles in the new universe. One collision might produce a cosmos with 5 fundamental forces, while another creates a reality where matter is inherently unstable. Our universe, with its perfect balance for life, is simply the product of one specific brain collision out of an infinite number, its parameters set by the precise way two cosmic membranes brushed past each other in the dark. A universe of pure energy is a cosmos without objects, a place where the very idea of a thing is meaningless. This reality was born from the same Big Bang as our own, but its initial conditions were profoundly different. In our universe, the primordial fireball expanded and cooled just enough for particles of matter to condense out of the energy, eventually clumping into atoms, stars, and galaxies. But in this parallel existence, the expansion was faster, the density lower, or the fundamental constant slightly altered. Matter never got its chance. The universe remains in its earliest, most violent state, a seething ocean of radiation where energy is the only currency. There is no darkness here, for every point in space blazes with light across the entire spectrum, from radio waves to gamma rays. It is a perpetual, chaotic sunrise with no horizon, a blinding fury of photons and other force carriers endlessly interacting. Without matter to absorb and re-emit this energy, there are no structures, no shadows, and no quiet corners. The very concepts of here and there lose their meaning in this featureless, luminous fog. Time still passes, but it is an empty duration with no events to mark its passage, no orbits or decays to serve as a clock. There is nothing to witness the relentless flow except the energy itself, a formless, boundless awareness without a mind to contain it. This is a cosmos of pure potential, where every possible interaction between waves of energy flickers into existence and vanishes just as quickly, a symphony played on an instrument with no strings. There is another you living your exact life at this very moment. Among the infinite variations of the multiverse, the laws of probability demand a reality that is a perfect atom-for-atom duplicate of our own. Every choice you have ever made, every word you have ever spoken, has been mirrored precisely in that parallel cosmos. The person you see in the mirror has a perfect twin, a cosmic doppelganger who is, right now, breathing in and out in perfect sync with you, feeling the same emotions and thinking the very same thoughts. This is not a universe that is merely similar. It is a precise replica, a flawless echo of our entire cosmic timeline from the Big Bang to this second. The coffee cup on your desk is in the exact same position there. The book you read last week is open to the same page. Every memory you possess, from your first childhood birthday to the minor frustration you felt this morning, is identically encoded in another brain, in another world. This statistical certainty emerges from the sheer, mind-numbing scale of infinity. If the multiverse is truly endless, then every possible configuration of matter must repeat, not just once, but an infinite number of times. The arrangement of every atom in our observable universe is just one specific pattern, and in an infinite cosmos, every pattern recurs. The distance to this perfect twin, however, is unimaginably vast. It is not in a galaxy far, far away, but in a reality entirely separate from our own, forever out of reach. You will never meet this other you, never exchange a single word or a knowing glance. Yet the profound intimacy of the idea remains. You are, in a very literal sense, never truly alone. Every private triumph, every secret sorrow, is being experienced simultaneously by another consciousness that is, for all intents and purposes, you. This leads to a deeply personal question about the nature of identity. If another being shares your exact history, your memories, and your physical form, what truly makes you, you? Are we unique individuals, or are we simply one specific instance of a pattern that repeats across the cosmos? Your life, which feels so singular and precious, is also a universal constant, playing out in a silent, endless symphony of parallel existence. The ultimate parallel universe is one that needs no space, no time, and no substance. It is a cosmos built not from atoms but from abstract truths, a silent domain of pure mathematics. This is the universe as a Platonic form, a perfect and eternal structure that exists independently of any physical manifestation. In this conception, our own universe with its galaxies and planets is not the primary reality. It is merely a shadow, a single, imperfect reflection of a much more profound and perfect mathematical form. The circles you draw on paper are flawed approximations of the ideal circle, a perfect geometric object that exists only in this realm of forms. Our entire physical cosmos is just one such approximation, one specific instantiation of a deeper mathematical truth. The equations that describe the motion of planets or the spin of an electron are not just human inventions. They are glimpses into this eternal landscape, a discovery of the timeless relationships that govern all of existence. In this ultimate multiverse, every possible mathematical structure has its own reality. A universe where geometry follows the rules of a four-sided triangle exists with the same validity as our own. A cosmos defined by a system of logic where 1 + 1 = 3 is not a fallacy, but a different kind of truth in its own self-consistent realm. These are not simulations or hypothetical models. They are realities as genuine as our own, their only requirement being that their internal rules do not lead to contradiction. We do not live in a universe that is described by mathematics. We live inside one specific piece of mathematics. Our consciousness, our perceptions, the very feeling of the wind on your face are all part of this particular calculation being run. The search for the theory of everything, then, is not a quest to find the laws of our universe, but to identify which mathematical structure we happen to be a part of. This idea brings us to the final, humbling frontier. If every consistent mathematical structure is a real universe, then the totality of existence is a silent, infinite library of truths, most of which are far too alien for any mind to ever comprehend. Our rich, tangible world of experience is just one beautiful verse in an endless epic of pure, disembodied reason. We have journeyed across 25 staggering realities, from the quantum branches that split with every decision to the silent, eternal library of mathematical existence. We have wandered through bubbles of space born in an eternal explosion, brushed against ghostly mirror worlds, and even considered the haunting possibility that our own minds might be fleeting cosmic accidents. Each of these visions, while speculative, is not mere fantasy. They are serious proposals born from the cutting edge of theoretical physics and the deepest questions of philosophy, each one an attempt to answer the fundamental puzzle of why we are here, in this particular universe, living this particular life. This incredible spectrum of possibilities, from the cyclical dance of colliding brains to the dark flow pulling us toward an unseen neighbor, reveals a cosmos far grander, stranger, and more interconnected than we ever dared to believe. It challenges our most basic assumptions about reality, identity, and our own significance. The question is no longer whether other universes exist, but what kind of multiverse we are a part of. So we turn this final thought over to you. After this journey to the edge of comprehension, which of these parallel realities captures your imagination the most? Which one, from the quantum immortality of your own consciousness to the perfect echo of your life in a distant cosmos, leaves you staring at the night sky with a renewed sense of wonder? Share your choice in the comments below. The conversation about our place in this vast, mysterious existence is only just beginning.